All right, so you want to remember that a power is a mathematical notation indicating that the number of times a quantity is multiplied by itself. So a power is made up of two parts. One part's called the base and the other one is called the exponent. So base is the number that you're going to be multiplying, and the exponent is the number of times you're going to multiply the base repeatedly. So for example, we can read the following as 2 to the power of 4. So my base is 2, which is the number I'm multiplying by, and the 4 tells me how many times I'm repeatedly multiplying it by. So 2 times 2 times 2 times 2 times 2, which gives me 16. So when we're multiplying powers with the same base, what are we doing with them? This is pretty simple. It should be from grade 9 and 10. We're going to add them together. We add the exponents together. So for example, when we have 3 to the power of 2 times 3 to the power of 3, the reason why we add them together is because we write 3 to the power of 2 as 3 times 3, and 3 to the power of 3 as 3 times 3 times 3. And as you can notice, we have 5 3s, so I can just write that as 3 to the power of 5. You don't have to solve it. Whenever I say write it as a single power, you just leave it as an exponent. If I say evaluate, then you're going to give me the answer. So the next one you have is 4 to the power of 2 times 4 to the power of 4 times 4. And whenever we have a number by itself without an exponent, we can always assume that we have an exponent of 1. Abby, what's the answer? Thank you. 4 to the power of 7. So yeah, so if you haven't been doing too well during the past trig units, yeah, this should bring your mark up by a lot. You're a decent amount. I skipped it. No need to. So now, if we add when we multiply, what do we do when we divide? Subtract. Does anyone know the reason why we subtract the exponents? Your grade 9 teacher should have taught you this. Why do we subtract the exponents? Why do we subtract? It's not a trick question. So 6 to the power of 5, I can write as 6 times 6 times 6 times 6. And 6 to the power of 2, I can write as 6 times 6. So when we have a pair of numbers that are the same that we divide together, what do we just get? What's 6 divided by 6? 1, which means I don't really need these guys. So again, 6 divided by 6 gives me 1. So how many 6s are left over? 3. Like I'm teaching my grade 9 unit 1 again, which is, yeah. And Jade, what would the next one be? 4 to the power of 4 divided by 4 to the power of 1. Yep, 4 to the 3. 3. And the last thing that we're learning is power of a power. So when we have an exponent raised to another exponent, what do we do with those exponents? Multiply. Yep, we multiply the exponents. I'm not going to show you why here because the exponents are too big and it's just going to take up a lot of space. So what would the first one be? 5 to the power of 3 to the power of 4. 5 to the 12. And then the next one is 10 to the 7 to the power of 3. What would that be? Wow. This is very easy, right? You say 100 times 100?
I just add the zeros.
You do? Yeah, Lisa, add the zeros. Okay. So now the next one, we're just going to do a bit of it. So what would the first one simplify to? When it says evaluate, I want you to come up with the single power and then tell me what the answer is. So 7 to the power of 2 times 7, what would that simplify into? 7 to the power of 3. And can someone tell me what that answer is? 7 to the 3. And don't say 21. You can use your phone. You don't really need a scientific calculator for this. 343. There we go. So, Elisa, what's the next one? 5 to the power of 2 to the power of 4 as a single power.
5 to the power of 8.
Yep. And can someone tell me what 5 to the power of 8 gives me?
I don't know how to do it. One, it should be like a million.
1 million?
What did you
Should be less than a million.
5 times 5 times 5 times 5.
390,625. So like I said, this over here is called a single power. And this guy over here is called the evaluate part. Evaluate. So evaluate just means give me the answer.
Oh my god, I know how to do this one. Oh, actually, I have a oh, you want to do it?
Okay, so for C, we have 3 to the power of 4 times 3 to the 8 divided by 3 to the 7. You're literally just going to follow BEDMAS. So we're going to do the multiplication first. So what is 3 to the power of 4 times 3 to the power of 8? Ashton? Nope. For multiplication. Yeah, we're adding the... Nope.
Oh, 3 to the power of 12.
Yep, whenever we only multiply when we have a power raised to a power. So we have 3 to the power of 12, and then we still have divided by 3 to the 7. So what would that give me? 3 to the 12 divided by 3 to the 7.
Wait, why is it 3 to the 12?
Because 3 to the power of 4 times 3 to the power of 8, all you're doing is adding these exponents together. Because you're multiplying exponents with the same base. So the first rule. So can someone tell me what 3 to the power of 5 gives me? 243? So 243. It's easy math, right? Okay, so D, try D on your own. Do the numerator first and then the denominator part after. Yep. Do D. Hey, hold on. Give me like a minute. I gotta charge this guy for 2 seconds.
Y'all put chocolate chip on my shoe?
I did. No.
Can someone tell me what they got for the numerator? Abby,
Is that
the top one. What'd you get? What's 6 times 6 to the 7?
No, didn't you add?
So what is that?
6 to the power of 8.
Yep.
Over 6 to the power of 6. And then that is 6 to the power of 2 because don't you subtract because, yeah. And then 36.
Good.
Oh, this is grade 11.
Yeah. I don't make the curriculum up. I just follow it.
Bulletproof backpack sales afterwards those exist.
Okay, and the next one should be pretty straightforward. When we have an exponent of 0, what does it always equal? Anything to the power of 0 gives me? No. 1.
Come on.
So anything to the power of 0 gives me 1. Yeah. So for the first one, I have 7 to the 4. It's getting too loud. Can I even hear myself? So we have 7 to the 4 divided by 7 to the 4. So I do 7 to the power of 4 minus 4, which gives me 7 to the power of 0, which gives me 1. So the reason why it's 1, do you guys know the reason why it's 1?
Isn't it 1 regardless? Like if any numbers are 0?
Yeah, but why?
Because there's only 1 7.
Nope.
Something times 0 is 0.
Nope.
Because you forget about it. Well, don't, like
No.
the base
No.
number.
Yeah. So if we take the powers of 2, for example, 2 to the power of 3, 2 to the 2, 2 to the 1, 2 to the 0, we know 2 to the power of 3 is 8, 2 to the 2 is 4, 2 to the 1 is 2. So 8 and 4, what do I divide by? 2. Divide by 2. So naturally, what's 2 divided by 2? 1. Which is why anything to the power of 0 is 1. And then when we get to the negative exponents, all you're going to be doing is dividing by 2. So 1 divided by 2 is 0.5 or 1 over 2. And as you can see, the positive exponent is just the reciprocal of the negative. So that's an easy way to remember also negative exponents. So which means a to the power of 0 is also going to be 1. Okay, and now for the last example, we're going to be dealing with negative exponents. So when dealing with the power with a negative exponent, we find the reciprocal of the base to eliminate the negative exponent, or we just flip it. So any whole number has a denominator of what? 1. So in order to make this into a positive exponent, all I'm going to do is flip it, and the only thing that turns into a positive is the exponent. Everything else stays the same. Okay, girls in the back, stop talking, please.
You flip it to make it a positive?
Yeah, you flip it to make the exponent a positive. So everything else stays the same. Even if the 3 was negative, the 3 remains negative. The only thing that changes is the exponent. Yeah. One. Yep. That would be the single exponent. If I ask you to evaluate, it's just going to be 1 over 81 because 3 to the power of 4 is 81.
So you would keep the 1 on the top?
Yep. So with that said, what would my next one be? So again, over 1, how would I turn that into a positive exponent? Remember, everything else stays the same besides the exponent. Yep. 1 over negative 7 to the power of 6. And can someone tell me what negative 7 to the power of 6 is? Remember, the negative is in the bracket, so if it's in the bracket to an even exponent, it should be positive. Yep. So again, the top part is your single power and the bottom is your evaluated answer. And now for C, we have 1 over 3 to the power of negative 4. So how do I change that into a positive exponent? Olivia? Yep. Yep, that's it. Work. So all you're doing is flipping the fraction. So it becomes 3 over 1, which is just 3, to the power of positive 4, which is just 81. Okay, now the next one, we have 5 over 6 to the negative 2. How would I figure that one out? Someone saying it? Yeah, Brooklyn?
I have a question.
Yep.
about the other question, about Z.
Mm-hmm.
Why is it a positive 4 now?
Because whenever you want to turn a negative exponent into a positive, you have to take the reciprocal of it. So which is why over here, so I have 2 to the power of positive 1 is 2, and 2 to the power of negative 1 is 1 over 2. If I want to change that into a positive exponent, all I have to do is flip the 1 over 2, and it becomes just 2 again. So you're just taking the reciprocal, so you're just flipping the base. So what's 5 over 6 to the power of negative 2? How would that change? Sarah? 6 over 5 to the power of 2. So each of these numbers have an imaginary exponent of 1. So whenever we have this type of question, you have to distribute this 2 into each of these exponents using the power of a power, which means we have to multiply the exponents together. So 6 to the power of 1 to the power of 2 just gives me 6 to the power of 2. And 5 to the power of 1 to the power of 2 just gives me 5 to the power of 2. So this can be written as 36 over 25.
But I thought if it was a power to a power of a power, you multiply.
Yeah, so 2 times 1
Oh,
is
sorry.
2, and then 2 times 1 is 2 again. Got a question? Oh. So as I said here, use power of a power. For the next one, like I said, what you're going to do first is you're going to start with your numerator and then work your way to the denominator. So for my numerator, I have 5 to the negative 4 times 5 to the power of 8. So how do I simplify? No, you don't flip it yet. How do I simplify that? I am multiplying exponents with the same base. What do I do with those exponents? Nope. It's the first rule. Add. So you're going to have 5 to the power of negative 4 plus 8. And for my denominator, I have 5 to the negative 3 to the power of negative 2. So that's a power to a power. So what do we do? Multiply. So 5 to the power of negative 3 times 2. So what's negative 4 plus 8?
Always some negative. Oh, it is.
Negative 4 plus 8.
On my sheet, it says 4 plus 8.
No. 4. So I get 5 to the 4 in the numerator. And what's negative 3 times 2? So 5 to the negative 6. So now because we're dividing the exponents with the same base, what do we do with the exponents? This is going to be 5 to the power of 4 minus negative 6. So what's 4 minus negative 6, sorry. Yep, so these two basically become addition. So I get 5 to the power of 4 plus 6, which equals 5 to the power of 10. And if I ask you to evaluate, what's 5 to the power of 10?
9, 7, 6, 5, 6, 2.
625? So that's the evaluated part, that big number. That's when you put 5 to the power of 10 in your calculator. Okay, so I posted the practice on Google Classroom, so work on that. You guys should be fine with this. So I think you guys will probably do very well on this next unit.